All right, I want to show you an example of regression with exponential functions. So here's an example, and this is looking at blood alcohol levels and its impact on the risk of being in an accident. So if your blood alcohol level is 0, your relative risk of crashing is 1. It doesn't mean you're going to crash, but just relatively, you'd be a 1. If your blood alcohol level is a little above that, then your relative risk of crashing is a little bit higher. If your blood alcohol level is 0.09, you're 3.5 times more likely to crash because of that. And you can see how it goes up. Like if your blood alcohol is 0.21, then you're 100 times more likely to crash. So let's see what kind of function this produces. So you want to get into decimals. Here's my decimals, and let me move it down a bit so I can see the data. And we need to go to the graphing calculator and then add a table. Okay, so input all those values in your table. I'll just pause while we both input them. Okay, I've got all my data in, I think. Yeah, they're all there. Hopefully I typed them all in correctly. Now I look at my graph and it just looks like a bunch of dots going up. So I'm going to shrink my graph. Well, and maybe let's use the settings tool to do that. So my blood alcohol level goes from 0 to 0.21. So my X values, I'm going to say from 0 to, I'll go 0.22. Okay, and then my Y values, the relative risk of crashing goes from 1 to 100. So I'm just going to go 0 to 100 there. Okay, so now I can see all my data there. And I look at it, and it doesn't look like a linear function, doesn't really look much like a quadratic function, maybe half of a quadratic. But it does look like an exponential function. The more you drink, the more likely you are to crash. There's probably a point where the exponential function ceases to be exponential. Like I don't know how high a blood alcohol consumption could be, like 0.5. Would the model still work if your blood alcohol level was that high? I'm not sure. And it depends on each situation. But for this data that we have, it certainly looks like an exponential function. So let's get a regression for it. So 1, y1, tilde, and then let's use the same one as that we've been using. I'm going to use p for the start one because we've been using p of t equals p0 e to kt. Let's use that. So y1 tilde, and then I'll just use a p instead of a p0, and then an e to the k times x1 there. So you take a look, and sure enough, that line sort of follows the data there. So if I go down below here, it tells me what my p value is, and it also tells me what my k value is. So let me just write those down here. So my function would be, you could say p of t, or I'll use y because that's what I have here. Y is equal to p0 value, or the initial value, 0.559, we'll call it. E to the k is 24.78, I'll call it, times t. Or x, maybe I'll use x up there. We've been using t's, but just with decimals we'll use an x. Okay, so there's the function that controls blood alcohol consumption and your relative risk of getting in an accident. So you can plug in any blood alcohol concentration there, and it'll tell you your relative risk for crashing. So they have 0.0, all these. Why don't we try 0.06? So I could say y is equal to 0.559 e to the 24.78 times 0.06. And that'll tell me relative risks of crashing if your blood alcohol is 0.06. Let's just do that in decimals here. Okay, so right down here, I need to go 0.559 e to the, and then in brackets, I'm going to write 24.78 times 0.06. Now notice that I rounded both those numbers a little bit, 3 decimal places, 2 decimal places. So my number might not be exact. On an exam, if I'm worried about it, I'll tell you how many decimal places to round things. Okay, so this says if my blood alcohol is 0.06, I'm 2.47 more likely to get in a crash. Interesting that this number here, is, I'm looking at 0.06, it would be in between those ones. So I would think that the number would be in between those two. But the data, as you can see on the graph there, some of the data is below the line, some of it's above the line. So that average line, that maybe 0.05 or 0.07, one of those numbers here, those two numbers might be a little bit out. But looking at all the data together, 0.06, my relative risk of accident would be 2.47 or 2.5. We could, well, I'll go 2 decimal places. Now, another way you could have done that is in decimals, is to gone down, if it let me, and just type x equals 0.06. And then it gives me a line. And notice that those two, if I zoom in a bit there, notice that the 2 dots there are lower than what the average line is, or what the regression line is. And if I tap, my tapping is not doing too well there. I don't know why it doesn't give me a spot where it crosses. Anyways, at 0.06, if I'm looking at there, I don't know exactly where I'm at, but it looks like I'm in the ballpark. This 2.47 is pretty close. All right, so there's an example of using regression with exponential functions. Good idea to practice that.